Last session we discussed about external features of cerebrum. In this session we will try to discuss about what are the different functional areas which are present in the cerebrum. Actually, cerebrum contains mainly three functional areas: motor, sensory and associated. Motor means they elicits or they will initiate the motor impulses. These motor impulses pass through the brainstem, spinal cord, and within the spinal cord they synapse with anterior horn cells. These anterior horn cells carries the motor impulses and reaches to the target organ and leads to contraction of muscles. Right? So this is motor. Then sensory areas. Sensory areas means if you stimulate any part of your body, we can record the electrical activity within the part of the cerebrum. That part what we call sensory area. Then associated areas. In associated areas, interpretation will take place. That means these sensations will be interpreted within the associated area. Right? Now we will see what are the different areas which are present in the cerebrum. Last class we discussed different sulci and gyri. Why there should be sulci and gyri? For better accommodation of brain within the smaller cranial cavity and to increase surface area. What is the surface area of brain? 2200 centimeters square. Right? So to increase surface area, cerebrum folded into sulci and gyri. Clear? Now we will discuss about functional areas. For that I am taking superior lateral surface of cerebrum and medial surface of cerebrum. So if you take superior lateral surface of cerebrum, this is superior lateral surface. This you know already. Last class we discussed in detail what are the different sulci and gyri which are present in the cerebral hemisphere. Then this is medial surface of cerebral hemisphere. So this is medial surface. Right? In the medial surface we have to draw corpus callosum. Of course, corpus callosum having different parts that you know: rostrum, genu, body, splenium, and here lamina terminalis, here fornix, then thalamus. Remaining other things also will be there, but I am not going to draw remaining things. Now if you see the superior lateral surface, what is this? You have to tell me. This is posterior ramus of lateral sulcus and this is central sulcus. Of course central sulcus will start from here in the medial surface. Then anterior to the central sulcus, pre-central sulcus, then superior and inferior frontal sulcus, here anterior ascending and anterior horizontal ramus of lateral sulcus, then here post central sulcus, here parieto-occipital sulcus. Of course parieto-occipital sulcus will be present in the medial surface, then it extends posteriorly and it winds around the superior middle border and appears in the superior lateral surface. Right? Then here one sulcus is there, one sulcus which is extending from the middle of the post central sulcus. This is intraparietal sulcus. So that parietal lobe divides into superior and inferior lobule. Then here can observe lunate sulcus, calcarine sulcus. Of course, calcarine sulcus is arising from the medial side and appears here. This is the calcarine sulcus, and here one sulcus is there. This is lateral occipital sulcus, right? Then superior temporal sulcus, inferior temporal sulcus. In the medial surface, this is cingulate sulcus and this is vertical sulcus. Here anterior and posterior para olfactory sulcus. In between these two, para olfactory gyrus will be there. In front of lamina terminalis, para terminal gyrus will be present, right? And if you observe in the inferior surface, here you can see uncus, and this is rhinal sulcus, this is collateral sulcus. Then temporo-occipital sulcus, right? So these are the different sulcus and gyrus. And one more thing we left. What is it? Suprasplenial sulcus. Clear? So these are the different sulci and gyri which are present in the superior lateral surface and medial surface, right? I am not taking inferior surface. Now, what are the functional areas? Functional areas are, I already told you, motor and sensory. But first we will see what are the different functional areas which are present in the frontal lobe. First, central sulcus. Anterior to the central sulcus, this is the gyrus. This gyrus what we call precentral gyrus. And this is anterior part of paracentral lobule. You know, this is paracentral lobule. Anterior part of paracentral lobule. Anterior part of paracentral lobule and precentral gyrus, unitedly called as primary motor area. Primary motor area. So this is primary motor area here. This is primary motor area. Now you know location, where it is exactly located. Anterior part of paracentral lobule and precentral gyrus. Even anterior wall of central sulcus also. Anterior wall of central sulcus also primary motor area. Right? Now, for this area, Brodmann given number as 4. 4. Actually, based on the laminar pattern of neurons, Brodmann given numbers to the different areas of cerebrum in 1909. Right? So these areas are Brodmann areas. Along with these Brodmann areas, according to their function, scientists are renamed. See here, this is motor in function. So we are calling this as primary motor, and this is sensory in function. We are calling as sensory area or somatic area. And here is visual area, here auditory area, right? Here speech area. Like this they renamed again. Right? Now, when we are discussing about area number 4, we know the location, anterior part of paracentral lobule, then precentral gyrus. This is location. Then, if you stimulate this region, what will happen? contraction of contralateral musculature, right? Along with that, they found some tingling sensation. Along with that, they found some tingling sensation. That means what? Tingling sensation means sensory, right? That's what this region, what we call M, capital M, small s 1, MS1, motor and sensory, but predominantly motor, right? So that is regarding stimulation and how body will be represented within the motor area or within the primary motor area. How body represented upside down means first toes here, then ankle, knee, then here hip, trunk, next shoulders, elbow, then hand, fingers, next head, that means face, next tongue, after that larynx. So representation will be upside down. Let me draw the diagram. For that I am taking section along the area number 4 and I will try to draw section here and I will show how body represented within the primary motor area. So I am taking from medial surface. So that surface I am taking from the medial surface. So this is medial surface. And what is this border? Superior medial border. The superior medial border. Then what is the surface? Superior lateral surface. This is superior lateral surface here. Of course, you know here is the lateral sulcus, right? So this is the superior lateral surface. If I take section and if I show here, now we will see the representation. This, of course, if you want to draw opposite side, it will be like this. But I am taking only one side, that will be sufficient. Right. Now here, first toes here, toes, then ankle, leg, knees, then thigh. Of course, in this medial region only there will be area for the perineum. That's what last session I told you. This region is responsible for the defecation and micturition, right? Then after thighs, then trunk here, right? After trunk, this is trunk, then what will be there? Shoulder, right? After shoulder, elbow, then this is elbow and this is forearm. Here what is this? Hand and tongue. I given more space for it. Why? I will tell you in the next step. Then neck, this is neck, then face. And this is mouth. I am drawing very big lips. So this is face. Next to the face, tongue. This is tongue. Then next to that means below, next to the tongue, here this is larynx, right? So this is the representation. This is the representation of body. This representation is upside down. Clear? So what does it mean? If you stimulate here, contraction of these leg muscles. If you stimulate here, contraction of thumb muscles. If you stimulate here, contraction of arm muscles, right? So that is the representation. Total body is represented upside down except face. Face is not upside down representation, it is vertically only. Clear? Then we have to discuss one thing. What we have to discuss? See here, I given more space for thumb, for face, for tongue and larynx. If you compare with remaining parts, why? Whenever we need more precise and coordinated and skilled movements, that places we need more representation. That means more neurons will be present over here, right? So fingers, mainly thumb and index finger, okay, they will do so many skilled things. And tongue, lips, larynx, we will speak and we will sing. For all those things we need more representative area in the brain, right? So that is representation. This representation, what we call homunculus, motor homunculus, right? So this is about motor homunculus. Clear? And if injury here, if there is injury to this area, what will happen? Paralysis, hemiplegia, contralateral side muscles paralyzed. This is what we are calling hemiplegia. Of course, some partial paralysis on same side, that what we call paresis. Why? This area initiates the motor impulses for contralateral side of the body mainly, but it will also initiate the motor activities of same side, that means ipsilateral side of head and neck and axial muscles, right? So that is lesion. If there is lesion, this thing will happen. Clear? So that is about area number 4. After area number 4, there will be one more area which is present within the same region. What we call area number 4S. Area number 4S. Area number 4S, it will inhibit any exaggerated movements or any exaggerated impulses produced by area number 4. So S stands for suppression. It will suppress the exaggerated movements. Clear? So that is about area number 4 or primary motor area. Next we will go for area which is present in front of the motor area. This area what we can call pre-motor area. Pre means before motor area. This is pre-motor area. This pre-motor area present in the posterior part of superior, middle and inferior frontal gyrus. Right? For this area, Brodmann given number 6. Of course, we can represent here also. Here is the 6 and here is 4. Then what is the function of area number 6? it will coordinate the voluntary activities which are produced by the area number 4. That means what? It will helps to precise movements, skilled movements, right? Very simple. Actually, area number 4 will produce some raw movements. Those raw movements are controlled and coordinated by area number 6, right? And scientists believe that it is the cortical center for the extrapyramidal tracts. Cortical center for extrapyramidal tract, right? Then, if injury to this region, what will happen? Skilled movements lost. Okay, skilled movements unable to perform, right? Then, if there is injury to 4 and 6, which leads to hemiplegia with spastic paralysis. Hemiplegia with spastic paralysis, right? Symptoms will be very worst. Clear? So, that's it about area number 6, right? Now, we completed premotor area also. Then, supplementary motor area. Supplementary motor area, which is present in the medial surface, which is present in the medial surface in this region. This region what we call supplementary motor area. What is the function of it? Supplementary motor area will controls the activities which requires sequential organization, right? So that means what? Very skillful movements like dance and all. For that, for sequential coordination and organization is needed. So those movements are initiated by supplementary motor area. Here also a representation is there. That representation is not like upside down, it is from anterior to posterior side. So in the anterior part of this region, head will be represented. In the posterior part, lower limbs. In the middle part, upper limbs, right? Then within that area there will be overlapping of sensory and motor, like here also motor and sensory is there. That's what MS1. How did they found this? When they stimulate here, they found voluntary movements. Along with that, some non-specific tingling sensation. When they stimulate here, they found some non-specific tingling sensation. That means that region contains some sensory neurons also. That's what that region is. MS, capital M, small s, MS2, right? So if there is lesion in that region, what will happen? Supplementary area lesion. What will happen? Loss of skilled movements. That condition what we call apraxia. Apraxia, right? Then we will see next area, which is present in the frontal lobe. Here, this region in the posterior part of middle frontal gyrus. That region what we call frontal eye field. So now we know the location. Now what we have to learn? If we stimulate, what will happen? If we stimulate this region, horizontal movements of eyes towards opposite side. That means if we stimulate right side, eyes will rotate to the left side, right? Horizontal movement of eyeballs, then dilatation of pupils and turning of head and neck, right? Along with that, it is responsible for the movement of eyelids. So these are the functions of frontal eye field. This region what we are calling frontal eye field. For this Brodmann given number 8, right? So how will you remember this? Actually you will write 8 like this, no? Instead of writing like this, you write like this and you put eyeballs here. Right? Horizontal eye movements. Then if there is injury here, what will happen? Deviation of eyes towards the affected side. Towards, that means affected side, this deviation will be there, and voluntarily he cannot rotate his eyes towards opposite side voluntarily, but involuntarily sometimes he can rotate. When if he is observing the moving object within his eye field, at that time involuntarily his eyes will move towards opposite side, right? That is in case of humans. If you injure this frontal eye field, if you injure this frontal eye field in animals, what will happen? Of course eyes will be deviated to the affected side, and if they wanted to walk forward, they cannot walk straightly. They walk or they move in a circular pattern. Circular pattern. Why? Eyes will be moving towards affected side and they can walk within their eye field only. So they will move around the circle. Right? So that is about frontal eye field. Right? Next. Below this, what is this region? Broca's area. Area number 44 and 45. But this what we call Broca's area. Broca apostrophe, yes. Broca's area. Then what is the function of it? See here, I am talking, okay, I am giving lecture. My lips, my facial muscles, my tongue muscles and my laryngeal muscles are contracting to give lecture. So all these muscles under the control of area number 44 and 45 of dominant hemisphere. In case of right-handed person, this Broca's area located in the left hemisphere. In case of left-handed person, it will be located in the right side. Broca's area, what we call motor speech area. Motor speech area. That means which is responsible for the contraction of muscles which are helpful for the speech. So this area what we call motor speech area. Right? Then if there is injury to this area on dominant side, what will happen? There will be motor aphasia or expressive aphasia. It is characterized by hesitant and distorted speech. That means what? Simply we can say effortful speech. Effortful speech means if you want to talk, he put so much effort. That speech what we call expressive speech. Right? So that's it about Broca's area. Clear? Then we will go for remaining part of the frontal lobe. This frontal lobe in front of this region, that means anterior part of superior, middle and inferior frontal gyrus, and also orbital gyrus, and also medial surface. That means this is what medial frontal gyrus and anterior half of cingulate gyrus. These regions what we call prefrontal cortex. For that Brodmann given numbers, area number 9, 10, 11 here, then here 9. Of course, I didn't write 8 here, it will be 8 here. 8, 9, 10, 11, 12. Right? Then, what is the function of this prefrontal cortex? Prefrontal cortex. So, what is the function of it? It is the center for the intelligence or sheet of intelligence, and it is organ of mind, and it also initiates the sympathetic and parasympathetic activities, that means autonomic activities. Of course, from here it will be connected to hypothalamus. From there, these autonomic activities will passes through the spinal cord and reaches to lateral horn cells. From there, it passes through preganglionic and postganglionic fibers. Right? Then it reaches to target organ. That was discussed in the first class. Right? So, now, what are the functions of it? I already told you it is a sheet of intelligence and emotions. It is a organ of mind. Right? Then what are the functions? We will see one by one. Concentration, attention, orientation, judgment, learning, memory, social behavior, and also activities which will occur in the autonomic activation. Right? So all these are the functions. Here, actually, in the initial part of the research on brain, they are stimulated this area, but they couldn't find any contractions in the body. So that they given the name for this area as silent area. But after some time, they stimulated with low voltage electricity, and they found activation of some systems like digestive system, cardiovascular system, excretory system, respiratory system, and also autonomic system. Clear? So, these are the functions. If there is injury to this region, what we call frontal lobe syndrome, frontal lobe syndrome. In that, how patient will be? He will be very aggressive, loss of concentration, loss of orientation, loss of attention, loss of recent memories. Of course, remote memories will be retained. Right? Then, loss of morals and social sense, and loss of judgment, loss of love and affection towards his family and friends, irritation, he will eat more, what we call hyperphagia. Right? So, these are the some of the symptoms in the frontal lobe syndrome. Right? So, with this we completed frontal lobe. Now we will go for parietal lobe. This parietal lobe, posterior to the central sulcus, this area what we call somesthetic area number 1. Somesthetic area number 1. So, this is the somesthetic area which includes posterior part of paracentral lobule, posterior part of paracentral lobule, and postcentral gyrus, postcentral gyrus. Right? Then, what is the function of it? How it works? Imagine if you apply any stimulus on the particular part of your body, you can record some electrical activities in this region. Right? This region, this somesthetic area receives cutaneous and proprioceptions, cutaneous sensations and proprioceptions. Cutaneous sensations is what? Touch, pain, temperature. Proprioceptions is what? Giant sense, vibration sense, and position sense. Right? So, these sensations will be received and interpreted by this area. For this area, Brodmann given numbers. Area number 3, 1, 2. 3, 1, 2. Right? We should not call 1, 2, 3. It's 3, 1, 2 only. Area number 3 receives cutaneous and kinesthetic sensations. Kinesthetic sensations means proprioceptions only. Kinesthetic sensations. and those sensations are interpreted by area number 1 and 2. Clear? So, in this area also there is overlapping of sensory and motor, but it is predominantly sensory. That's why this region we can call as SM, capital S, small m 1, SM1, SM1, right? Then if there is injury here in this region, now we know the function, it receives the sensations, cutaneous and kinesthetic sensations, but if there is injury to this region, what will happen? Loss of cutaneous and kinesthetic sensations. Mainly there will be loss of tactile discrimination, tactile localization, joint sense and position sense. What is tactile discrimination? What is tactile localization? Just imagine, I close my eyes, if any one of you come and touch with your finger or with any object on my hand, I could notice that one marker or something it has touched on my body. If you keep two markers, then I could notice that yes, two objects are touching on my body. That means what? Discrimination, 2-point discrimination. If one of you come and touch with any object or with your finger, I could notice that yes, one object is touching my body, it is just 5 centimeters above my wrist. That is what? Localization. I could localize the area, right? So that is tactile localization. Those will be lost, and joint sense, position sense also lost because loss of kinesthetic sensations, right? But crude pattern of senses of pain, cold and hot will be retained. Then how it is represented? How it is represented? Like motor, here also sensory representation is there. That what we call sensory homunculus. That means what? If you stimulate here, somewhere here electrical activity will be noticed. That means here it is wrist, here wrist. If you stimulate here, here electrical activity will be recorded, right? So that representation, that sensory representation, what we call sensory homunculus. Almost sensory homunculus also similar to motor homunculus, but here neck is present after thumb, no, but here neck is present in between shoulder and trunk, here neck, right? So it is represented like this, that to contralateral side. Contralateral side means what? If you stimulate here, in my right hemisphere electrical activity will be recorded, like motor only. This is sensory, this sensory information also recorded in the contralateral side, right? So that is about sensory homunculus. Clear? Then we will see somesthetic area number 2. It is present in the upper margin of posterior ramus of lateral sulcus. That means somewhere here. Here is somesthetic sensory area number 2. Right? In this also some motor neurons are there. That means it is predominantly sensory, secondarily motor. This is SM2, this is SM1 and this is SM2. Clear? And it represents bilaterally, here contralaterally, here bilaterally. That means it receives sensation from the both sides of the body. Clear? So that is about SM2 or somesthetic sensory area 2. Now we will see area which is present behind the postcentral gyrus. Superior parietal lobule and inferior parietal lobule. In the superior parietal lobule, we can find area number 5 and 7. Area number 5 and 7. Clear? So, what is the function of it and what we call this area? Sensory association area. These areas what we call sensory association areas. Sensory association regions means what? They will interpret the sensations which has received. Right? So, this is association area. There will be higher association area. There will be higher association area which is present just above the supramarginal gyrus. It is area number 40. What is this? Higher sensory association area. Simply we can call area of stereognosis. Area of stereognosis. What is stereognosis? I am closing my eyes, and if any one of you come and give this object, I will touch like this. I will see the size, shape, texture and tone of this object, and I could identify as a marker. That means identification of objects by means of touch sense. That what we call stereognosis. Stereognosis. Right? This is stereognosis. If there is injury to these regions, what will happen? Astereognosis. That means unable to identify the object by means of touch sense. Right? So, that is about, this is sensory association and this is higher sensory association. Clear? Simply area of stereognosis. Clear? Then we will go for occipital lobe. In the occipital lobe, this is lunate sulcus. This lunate sulcus separates the striate area from the parastriate area. Along the lips of it, we can find peristriate area. Right? Why we are calling this area as striate? We can find some bundle of fibers with naked itself. Those bundles what we call stria genneri. Stria genneri. Otherwise, we can call this as a outer band of bilateral. Outer band of bilateral. These things I will explain you when I am telling about histology of cerebral cortex. What is band of bilateral? Right? So, here this is area number 17, that is striate area. Area number 18, post-striate area. Area number 19, peristriate area. So, here if you want to see, here area number 17, here 18, here 19, here 18, here 19. Right? So, these are visual areas. First, if you take area number 17, this is primary visual area. Primary visual area. What it will do? What is the function of it? Reception and perception of isolated visual impulses of size, shape, color, motion, translucency. All these things will be received and transferred to area number 18 and 19. Now, area number 18 and 19 are associated visual areas. Associated visual areas. These associated visual areas interpreted these visual impulses and compared with past memory and recognition of object. That means, let me give you an example. I am giving lecture here. Then if I see from that window, some person will be coming towards me. From very long distance, I could see him and I could identify that he is human being coming from some distance. If it comes bit closer to me, I could identify his dress and height and walking style and how much speed he is coming towards me, that I could identify. Once it reached near to me and I could see his face, that means shape of the nose, eyes, face, all these things I could see, and those impulses I will receive by area number 17. Then from here, these information what I have received, it will be transferred to associated area. In the associated area, these information will be compared with past memory. Then I will identify as particular person and I will tell his name and I will call him with name. If I know, that means if I have past memory regarding him in this area, right? So that is visual association area. Then there is one more area, that is higher visual association area. Higher visual association area, that is area number 39. Mostly it is present above the angular gyrus, right? So what it will do, what is the function of it? It stores and recognizes the objects. It stores and recognizes the object. Clear? So if injury to these regions, associated regions, what will happen? He could see, right? But he couldn't identify the objects. He couldn't identify the object. And if examiner write any word, he couldn't read properly that particular word. Actually he knows before injury, but now he couldn't read that word. And whatever he wrote, the patient himself, he wrote some word and he couldn't read that. So that condition what we call word blindness. Word blindness. That condition what we call word blindness. Word blindness. Word blindness. Right? So that is about visual areas. Clear? Then coming to the temporal lobe. In temporal lobe, actually this is superior temporal gyrus, middle temporal gyrus, inferior temporal gyrus. When I am explaining about sulci and gyri, I told you that when you remove this frontal lobe and parietal lobe, in the upper part you can see structure like this, and here in the anterior part, anterior transverse gyrus and posterior transverse gyrus you can form. This is anterior transverse gyrus and this is posterior transverse gyrus, right? In this anterior transverse gyrus there will be area number 41 and behind that area number 42 and here area number 22. This area we can also call as vernix area. Clear? Now what is this area called? This area what we call transverse gyrus of Hessel. Transverse gyrus of Hessel. Transverse gyrus of Hessel. Within that we can form area number 41. Clear? Then behind that area number 42, just most posterior part, area number 22. This area we can also call as vernix area. Clear? First, area number 41 is primary auditory area. Primary auditory area. What is the function of this primary auditory area? Reception and perception of isolated auditory impulses like direction of sound, frequency of sound, pitch of that sound. All these things will be received by area number 41 and it will be transferred to associated area. Actually this is 42 is associated area and this is higher associated area. This is associated area and this is higher associated area. In this associated areas, what it will do? It will compare and contrast. That means it will compare with past memory and it will recognize the sound. That means how it will recognize? Just imagine we are taking lecture here. If we get some sound from that road, that sound will be received by area number 41, then it will be interpreted by 42 and 22, then recognize whether it is sound from some vehicle or sound from some mobile, that means like music, right? If it is music, what will happen? Further integration, further interpretation, then again compare with past memory, then recognition of that sound from which movie it is, right? So that is area number 41, 42 and 22. Clear? If there is injury to this area, he cannot hear, and if there is injury to this vernix area, which leads to sensory aphasia. Sensory aphasia. Sensory aphasia means he will be speaking very fluently with frequent incorrect and empty words. Within his sentences, some incorrect and empty words will be there, right? So that speech, what we call sensory aphasia. Sensory aphasia, right? So that condition we can also call as word deafness. Here word blindness, no? Here word deafness. That is about temporal lobe. Then we will see one more area which is present here. This area actually it is present in the dorsal wall of posterior ramus. Dorsal wall of posterior ramus. This area is area number 43. Area of taste. It receives taste. Actually, it will be continuous with the insula. Clear? So next class we will discuss about white matter of cerebrum. Right?